Okay, so we're going to continue looking at wave mechanics. Let's see. Next one that we're going to take a look at. The frequency of oscillation of the wave emitted by an FM radio station. So they're telling us that the frequency of this FM radio station is 95.6 megahertz. At least those are the numbers I have. Find the period of vibration. Radio waves travel at the speed of light, which means that they have a speed of 3 times 10 to the 8th meters per second. Now, this is one that I introduced briefly in class, but we didn't talk a whole lot about, so I wanted to have a video to go along with that. Period is the time it takes for one cycle. We talked about this back when we dealt with orbital mechanics, objects that were orbiting others. And frequency, as we've been talking about recently, is how many cycles per time. It turns out that these two are inversely related to each other, so our period will actually be equal to 1 over our frequency. Well, we've got a frequency here. It is 95.6 times 10 raised to the positive 6th megahertz, mega being times 10 to the 6th. Okay, so what I need to do then, if that's my frequency, I need to take 1 divided by that, and we should find that the period, the time it takes to make just one wave. So the period is going to be equal to 1 over our frequency, and what I end up with is 1.046 times 10 to the negative 8 seconds. It takes about 10 nanoseconds for us to make one wave. That's a whole lot of moving very quickly. In fact, that's pretty much what you talk about with visible light altogether. Let's double check our answer. Let's see, they've got it listed in 10.46 nanoseconds. Did they say answer in nanoseconds? I have no idea. Should be fine with this. They might actually accept nanoseconds as well. I just naturally put it into a regular unit. All right, but that's how you find the period. It is 1 over the frequency. Now, the second part that we're going to look at, they ask, find the wavelength of this wave. Okay, great. Well, we're going to use the equation that we've done before. The speed of this wave, which is light, is going to be equal to the speed of light, which will be the wavelength times the frequency. So we get 3 times 10 to the 8th meters per second equals our wavelength times our frequency, which we said was 95.6 times 10 to the 6th hertz, megahertz. So a little bit of math here. See, 95.6 times 10 raised to the 6th. 3 divided by answer times 10 raised to the positive 8. We actually end up with lambda for our radio wave is 3.138 meters. Now, radio waves are usually kind of long. In fact, for a lot of the regular broadcast ranges that we use for commercial radio, it'll probably be around 3 meters is going to be the wavelength there. But feel free to check them individually. You're going to need a more precise answer for our system.